All right, guys, today we're going to be doing 2b.1b. Again, that's a mouthful. We're going to be talking about composition of functions today, which is kind of part two of what we did a couple days ago. And our mission is I can find the composite of two functions. As always, I want to try to start with something familiar that maybe you've done before and then try to work into our new content. I think it's better for us to try to, again, look at something we already know, and it gives us a little bit of confidence to be able to do what we need to do next. So let's go ahead and start here. Let's say we got 3, and I've got a bracket and a parenthesis, 4 plus 7 times 3, and then we'll end bracket. Okay, brackets are something maybe we don't see a whole lot, but I wanted to use this just to kind of try to get us familiar with it, as well as just think about how would you go about solving this particular problem. Remember that we always, especially in grade school, we use please excuse my dear Aunt Sally, or PEMDAS. I want you to think about what each part of this is when we talk about order of operations. P obviously is parentheses, E is exponents, M and D is multiplication and division, and A and S is addition and subtraction. I want you to think as well that this parentheses could also be brackets, okay? And so exponents could also be square roots, okay? So we actually need to expand this definition just a little bit so that we can understand how we need to do this. But this is the typical order of operations that we would start in. So we would always start with our parentheses. But you notice I've got some brackets here as well, okay? And really what I want to do with the reason I'm using this problem is I want you to understand that really in order to solve this, you kind of have to work from the inside out, okay? I'm not even really worried about this 3 that's out here on the outside right now. All I'm worried about first is trying to get the inside kind of solved. So where I would start is I would actually start with these parentheses right here and go ahead and do that work first. So our 3 would just kind of hang out here to the outside. We could keep our bracket, it would be fine. So then I would have 4 plus 7, which is 11 times 3, okay? And now at this point, even though I do have multiplication out here, I want you to understand that I still have a set of brackets. And so the thing inside of the brackets, again, here needs to be done first before I go ahead and multiply. So at this point, then I would have 3 times 11 times 3, which is 33. And so my final answer for this one would be 99, okay? And again, I just want you to see that the beginning of how you start is you're going to have to start here and work from the inside out, okay? So you say, what in the world does that have to do with composition of functions? Well, let's just, let's suppose that we have f of x equals negative 3x plus 2. And let's say g of x, which is a different function, is 5 minus x. Okay, so we have these two functions, and I'm gonna introduce you to some notation that's going to be kind of crazy, and I really don't like this notation, but it's something that they use a lot in college algebra, especially, and so I want to show you how to kind of resolve that a little bit. So the notation is like this: the f, and then you have this symbol. Okay, this is, and we'll talk about that in just a second. And then g, and then let's say of negative 2. We're going to work an example here. So what I want you to see, it kind of looks like fog, okay, but this could just as easily be g and then this symbol and f, okay? So really what this is, and the way you word this is f of g of negative 2, f of g of negative 2. And so this is not, this is not a multiplication symbol, okay? Because again, a multiplication symbol is a closed circle. This one's just an open circle, okay? So the way you read this again, it's pronounced f of g of negative 2. Really what I would encourage you to do is to rewrite it a different way, and I'm going to show you how to do that right now. So the way you would rewrite this is just keep your f the way it is, just like that, okay? What you need to do is change this to a parenthesis. And so really what you have is f of g of negative 2, like that, okay? And it's going to kind of make more sense as we get into this just a little bit. But it's the same exact thing. It's just notated a little bit different. but it'll make more sense, I think, as we go through this. So what I want you to think about is, again, back to our original problem that we started with, we had to work from the inside out. So it's the same way with composition of functions. When you're told to compose a function and you're given some kind of problem like this, what they're really asking you to do is to work from the inside out. So we're going to do g of -2 first, okay? So let's just think about what really you're doing. What you're really doing is taking this g function, which is right here, and you're putting -2 in for everywhere that you see x. So let's write this out. G of x right now is 5 minus x. All I did was I just took this and just brought it down here, okay? Now what I'm going to do is I'm going to take this -2 and I'm going to put it everywhere that there is an x. So again, g of -2 would be 5 minus a -2. I'm just simply putting this -2 right here in for my x. Now let's go ahead and finish solving this. So g of -2 equals 5 minus a -2. We're going to do 5 plus, right? Keep change. So 5 plus 2 actually equals 7. So what I want you to see is now this right here, g of -2, I actually have a number for that. G of -2 is actually 7. So what I want you to think about is if g of -2 is 7, then now I can put that 7 back in up here. So think about what we really have now. Now what we really have is f of -7. Now that's really what I need to solve. You can kind of see how we went from the inside out. We solved the g function first for -2. Once we got an answer, I'm going to take that answer then and plug it in for my f function. Okay, so f of x equals -3x plus 2. I got that from up here at the top, right? F of x equals -3x plus 2. So now I'm simply going to substitute in a 7. That was not a -7. I put -7 up there. Y'all probably wondering where in the world that come from. I was just kind of freaking out, I guess. So f of 7 equals -3 times 7. Again, I'm substituting in this 7 everywhere I see x in my original function, plus 2. So f of 7 equals -21 plus 2, which equals -19. Ladies and gentlemen, this right here would be my final answer, -19. Okay, so again, I just take my two functions that I'm given and I work from the inside out. Okay, so let's look at those same two functions, and we're going to do it a little bit different this time. So f of x equals -3x plus 2. G of x equals 5 minus x. This time we are going to do g of f of 1. Okay, so again, the first thing I'm going to do always is I'm going to rewrite my function. So I'm going to rewrite it as g of f of 1 and just close my parenthesis. And again, I'm always working from the inside out. So with this, like this, I'm going to do the f function first. So let's do f of x equals -3x plus 2. Instead of an x, I'm going to put in a 1. Let me color that. That'll make that a little bit more clear what I'm actually doing here. Okay, so -3 times 1 plus 2. So f of 1 equals -3 plus 2, which means that f of 1 equals -1. Okay, so now that I know that f of 1 equals -1, okay, this quantity is the same as this. Now I can do g of -1. Okay, so now let's do g of x equals 5 minus x. Again, now I'm going to do g of -1. So it equals 5 minus, again, a -1. So g of -1 equals 5. Again, this is 5 minus a -1. 5 minus a -1 is going to become positive. So 5 plus 1 equals 6. So there we have it. Here would be our final answer right here. Okay? So g of f of 1 actually equals 6. Now, you may be thinking to yourself, why in the world does this even matter? Why are we even doing this? There's no way we're ever going to use this in real life. Well, I'm going to tell you that this is absolutely something that you will use in real life. So let me give you a scenario here, and I think this will help us to understand this. So let's say, for example, and this is just a practical example we're going to do. Let's say that a video game store adds a 25% markup. Okay, 25% markup on all the games that it sells. And in addition to the manufacturing cost, the store also pays $1.50 shipping charge on each game. Okay. So markup, obviously, when a store sells you a product, they have already bought it for one price, let's say $10. Well, then they don't sell it to you for $10, obviously, because if they do, they don't make a profit. So there is something called a markup. So this particular store is going to mark up by 25%, and then they also have to pass along to you a charge of $1.50 for shipping charge. So then let's write two functions that kind of expresses this. So let's do one function for the 25% markup. Okay. So if you think about this, f of x, we'll just make it f of x equals x, because I don't know what the cost of the video game is, but I know that I'm going to multiply that. Let's just think about this for just a second. If you got $10 for a game, and then you multiply it times 25%, then you've got to take that 25%, which is $2.50, and then you've got to add it back to that $10. So that makes it $12.50. So let's just kind of think about what really needs to happen with this formula then. So I'm taking x, whatever it is, I'm going to multiply it times 0.25, but then I've got to add that back to x again, okay? So just think about what really happens here. You've really got, and let's rewrite it here, you've got 0.25x plus x. Well, what does that end up becoming? Really, there's a 1 right here, right? Always in front of any variable. So really what I have is 1.25x, and that's a good, quick, easy way to do a markup. If you're marking something up by 25%, just take 1.25 times whatever you're going to actually buy the product for, okay? So f of x here we have figured out is 1.25x. Now let's think about adding this shipping charge. Well, again, I've got g of x, and I've got a certain price I'm going to pay for the product to come in, but as soon as that product comes in, then I have to add, right, shipping charge, I have to add $1.50. So you kind of see we have two separate functions here. We've got a g of x function here. We've got an f of x function here. The question becomes, suppose that the manufacturer cost for the video game is $13. So let's just say that instead of $10, it's actually $13. Okay? Now, the question becomes, which way is it better? Is it better if the store applies the markup and then the shipping charge, or is it better if they apply the shipping charge and then the markup? Okay, believe it or not, it does absolutely make a difference. Order matters, and this happens all the time. Actually, the problem you're going to have in your practice has got to do with car sales, because they do this kind of thing all the time. They'll say, "Oh, I'll give you $1,000 rebate, and I'll do this and I'll do that." But what you don't realize is they understand which order they need to do it in. Okay, so let's just imagine for just a second that we are going to apply the shipping charge first. Well, now how do we need to write that? Again, that means if this is my shipping charge right here, that means that I need to do this part first and then apply the markup. Well, the markup is my f of x function, and the shipping charge is my g of x function. So I need to do the g of x function first. So I want you to think about this for just a second. Really what I'm saying is I want to do f of g of 13 like that. I want to compose a function. And what reason I wrote it like that is I want to do this G part of this first. I want to do the shipping charge first to see what happens. So let's think about this for just a second, and let's go ahead and work this out, see what happens. So this is example one where I'm applying the shipping charge first. So if I put 13 in for the g of x function, I'm going to have 13 plus 150, which is 1450. So there is g of 13. Now I want to take that 1450 and I'm going to put it into the f of x function. So f of x equals 1.25x. So f of 14.50 is 1.25 times 14.50. And let's see what this equals. 1.25 times 14.50 is going to be 1813 basically after you round it. Oh, I'm so sorry. Go back. I hit the screen with my finger and it went crazy. All right. So again, if I apply the shipping charge first, it is going to cost $18.13 is what I'm going to be able to charge the consumer. Okay. Think about it from the store's perspective. Now let's do that same thing again, but this time let's apply the markup first. So in other words, I'm going to do g of f of 13. And again, you may be thinking to yourself, Mr. Hamilton, this is not going to make any difference whatsoever. Well, let's just make sure. So if I do the f of x function first, f of x equals 1.25x. So f of 13 equals 1.25 times 13. All right, so let's think about what that is going to give us here. Let's see, 1.25 times 13 equals 16.25, okay? Now, what do I have to do? I have to take this answer again, which is the same as this, and I have to put it in for the g of x function. So g of x equals x plus 1.5, right? This is that shipping charge. So now we're going to do the shipping charge second. So 16.25 plus 1.5 is going to give me 17.75. Now I want you to just think for just a second. If I am the store, not the consumer, but I am the store that is selling this to a consumer, which one do I want to do first? Well, obviously, I want to charge the consumer more, the most I could possibly do, so in order that I could make a larger profit, right? So again, here are my two amounts, $18.13 and $17.75. Doesn't seem like much, but if I sell 1,000 of those, that's gonna be a pretty good chunk of change. So again, if I am the consumer, I want to make sure that if I am the store, I want to make sure that I am applying that shipping charge first, right? And then adding my markup. So again, this is using business all the time. So you do have an application question set that you're going to have to do that's related to car sales, but it's going to be set up very similar to the way this one is. I want you to just think about probably the hardest part is just trying to figure out exactly how these two things need to be set up. Once you get them set up, then you just compose your functions based on what you want to do first. Okay. Hopefully this has been helpful. And again, hopefully this is something that you can see that is very useful in the real world. Not only that, but in college algebra as well. Okay. So have a great day today and make sure you contact us if you have any questions or concerns.